Okay, so today we're going to talk about force, and force is a push or pull on an object. This can be a person, it can be any inanimate object, any living object, but it's the push or pull is the force, okay? So her example here is a person sitting in a chair, and the person is creating a force of 50 newtons downward, and the chair is exerting a force of 50 newtons upwards. So therefore, this is a balanced force because the net force is 0. Now the N in 50N equals newtons, not north, okay? If you write north, that's no, bad, okay? Newtons is the unit that we use to measure force. So anytime you have a force question where you have to calculate the force, make sure that you're labeling your answer with the N, which represents newtons. Now let's talk about gravity. Gravity is a force that is the attraction between two or more objects that have mass. Okay, so the strength of the gravity depends on the mass of the objects and the distance between them. So, for example, we have these four diagrams that I drew here, and the first diagram has two objects in it. One is larger than the other, and the distance between those two objects is very small. So that means that the strength of the gravitational force in comparison to all these other diagrams is very strong. If we look over here, you'll have two smaller objects. The distance between them is longer, which means that this diagram out of all of these has the least gravitational force, and that it's very weak. So our real life example of this is the Sun and Mercury versus the Sun and Pluto. Now these planets are very small in size, and they'll both have a gravitational relationship with the Sun. So the question is, which one has more gravitational pull to the Sun, Mercury or Pluto? Now the answer is Mercury, because the distance between the Sun and Mercury is very short in comparison to Pluto, which has the farthest distance away from the Sun. Okay, so I'm going to use my friends to help you understand basically how gravity affects weight and mass, and how gravity can affect how things fly through the air. So our first example is going to be the smallest little red bird that you get on that first level. It's the first bird that you get, and they fly very far. That's because they have less mass. They don't do a lot of damage because they don't have a lot of mass. The second bird that we're going to talk about is I like to call them the large red boulder birds, because they are really big in comparison to the little red bird, and it's harder for them to be shot far distances because their mass is so large. But because they have that large mass, they do a lot of damage. Today, for our example purposes, we'll be using the blackbird because... Okay, so as I was saying, the bird that we're going to be using today is actually the blackbird, which is similar in size and will be enough to give my example, because I haven't gotten far enough in the levels to be able to show the fluffy bird for this example today. The third bird that we're going to be using is going to be the white bird that shoots the egg, and these egg-laying birds also take more force to shoot because they're larger in size. They're carrying that egg, and then when you drop the egg, that's what we need to pay attention to, is what happens to the bird after it loses its mass based on the force of it dropping its egg. And after it drops its egg, it shoots off in the other direction because it's lost its mass, and the force of shooting the egg out causes it to fly away. Okay? So the question we're going to be asking, or I'm asking you today, and what we're going to be experimenting with, is what is the difference between regular Angry Birds and outer space? Because how these birds react in outer space will be different than how they react on Earth. And in order to understand this concept, you need to know the difference between mass and weight. So mass is the amount of matter in an object. And if I take my mass on Earth, let's say 100 grams, which obviously isn't even close, but if I take my mass on Earth of 100 grams and then go to the moon, my mass will be the same, unless of course I lose an arm on the way there, which is very unlikely. If I am already going to the moon, I would probably be very excited, and losing arms would be the last thing I would want to do. So if I take my mass on Earth, which is 100 grams, and then I take my mass on the moon, it would also be 100 grams, because gravity does not affect the amount of mass in an object. My mass will stay the same. Weight, on the other hand, which is the amount of gravity pushing or pulling down on an object. So if I weigh 100 pounds on Earth, I'll probably weigh about 28 to 30 pounds on the moon, because there's less gravity on the moon pushing or pulling down on me. Now, what you need to take away from this is that mass and weight are not the same. Okay? No, bad. You need to make sure that you understand the difference between these two, because if you don't, then you're going to have some trouble with your test questions. Okay, so let's take a look at a couple examples of what I'm talking about with Angry Birds. Okay, so the first level we're going to look at today is the first level. Oops, that's not it. The first level we're going to look at today is the very first level, and that's the one that you get when you get the first 3 little birds that you use to play the game. Now, obviously, the purpose is to kill the piggies, but the game is to kill the piggies, but today we're learning about how the birds fly. So if I were to shoot my little red bird very high up in the air, I want you to pay attention to how high it can go based on the trajectory I'm using, because we're going to compare it to the blackbird and the white bird in a minute. So I want you to pay attention. Do you see how the screen actually raises up, because that's how high I can get that bird to go into the air just by shooting it in that direction? If you look at the other birds that we're going to talk about today, like the blackbird, if I hold that one up, notice it doesn't go high enough to raise the screen, which means that its mass does affect how it behaves. Now let's take a look at, the mass does affect the amount of gravity pulling down on it. So if we look at the white bird, I don't want you to pay attention to what the egg does. I want you to pay attention to how the bird flies after the egg is shot, because what should happen is that the bird will continue to fly at a faster rate right off the screen once you shoot that egg. Okay, notice it went off in a diagonal area. So let's just see that again, just so that you guys understand. I'm just going to get rid of that wall right there so I can do this the right way. If you shoot it right up the black bird, notice it doesn't go as high as the red bird did. And then we'll go ahead and do the same thing with the white bird. As I shoot it and then the egg goes, off goes the white bird. Okay, so the question I had for you was, how does this affect the outer space aspect? If we don't have gravity, how will these birds react with no gravity? So here's my red bird, and because it's in outer space in the diagram, I'm gonna shoot it straight out, and notice there's no gravity to bring it back down to the planet right here. And this is what I want you to pay attention to, is here's the planet and here's the gravitational force. Okay, so I want you to pay attention to the size of the planet, because we're going to look at a couple different ones, and the gravitational field around. So if I take my Angry Bird and I aim it just to the outer area of the gravitational pull, pay attention to what happens to the bird as it gets sucked into the gravitational pull. You'll notice that it'll go around the planet a couple times before it actually hits what you want it to hit. This is because the gravity on the outside of the gravitational field isn't as strong. So if I take this bird and I shoot it to the middle, between the middle of the gravitational field between the outside and the planet, you'll notice that it'll actually hit the ground much faster, and it goes right to where I want it to go, and it doesn't go around the planet a couple times. Okay, so let's take a look at another level 5, and this is we have 2 planets here. You'll notice that this one is slightly larger than this one, causing it to have a larger gravitational field around it. Now, because this one has a larger, stronger gravitational field, when I shoot it into this field, this one will actually grab onto it, causing it to go into the second gravity field, and then will float around this side, this planet, and in a centripetal force motion, because anytime we're going circular, that's going to be a centripetal force. Now, the last thing I want you to look at is right here. We have this last little bit up here, and I'm not sure if you can really see it because it's dark, but there's a mountain right here. And when I shoot my bird up here, I want you to notice how the bird reacts after it hits this object and it floats down here and then hits the gravitational field. I want you to pay attention to the acceleration of the bird at that time, because what you'll notice is as it's falling, it's going to fall down pretty slow, just kind of float, and as soon as it hits that gravitational force, it goes down very quickly, hitting the pig that you want it to hit. And it's just because this distance between here and here is shortened, which means the gravitational pull is much stronger.